Hi guys, I'm back. We're going to do another example here of counting on a hemacytometer and then following up with the calculations. Most of my other videos either had just one side on there, we talked about count, or we just talked about the calculations. So now we're going to actually put both sides of the hemacytometer together and we're going to do the calculation. So we're going to follow through. This one's just going to be, we're going to focus on white blood cells. So here's our WBCs right here. And we're going to start on, this will be side 1 and this will be side 2, or A or B, however you'd like to refer to it. We're going to count these in our first square here. I guess if I used a highlighter it'd be a bigger box. Oh, well, that's not helpful. Okay, here we go. So we're going to count 1, 2. Remember top and left, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And if you had a clicker, you would just keep going until you completed the whole side. So 14. I'll add mine up at the end because that's a little easier when I'm talking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8. Now I have to do some quick math here for you. So 14, 12, 26, 36, and oh wait, did I do that right? Yes, 36, and 8 will be 44. So down here we'll count real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10, 13, 23, and 9 is 32 plus 9, which is 41. So now we have, for our two sides, we have 44 and 41. So now we're going to scroll down and we're going to take a look at our calculations. Okay, so I'm going to write these, transpose them down here so I have them. So 1 is 44, 2 is 41. And so the very first thing we have to do is see if they agree between sides. So what is our percent difference between sides? And depending where you work, how many cells you've counted. Right now, let's see, we have, in our lab that we did, it was less than 20% or plus or minus 5. Whoops. Let me fix that. Plus or minus 5. So we are plus or minus 5. So our counts are good between sides. Now, the next thing we're going to take a look at is our actual count for WBCs. So we do, in order to report this, it's number of cells per microliter. Okay, and the calculation for that, in this one we're going to look at is the average number of cells, times any dilution factor, and that is all divided by the number of squares counted, number of S squares counted, divided by the volume of one of those squares. 1 square. So we'll put that on there. Okay, so what we're going to do here for our white blood cells, we're going to go ahead and we will average those. So we have 44 and 41. I think we're going to have a 0.5 here, but let me do the calculation. So 44 plus 41 divided by 2. We have 42.5. So our average is 42.5. Okay. So in our calculation, we'll put 42.5. And I didn't tell you that we had any dilution, so we're going to do this initially with no dilution factor. Okay. Now, since this is an average, okay, so how many squares did we count to get an average number of cells? So total, we counted 8 squares. Okay, so that's total. We counted 8. But since we averaged them, we took an average, A-V-E-R-A-G, average of 4 squares. Okay, see how I got that from? So our average is just for one side, and on each side we counted 4 squares. So we're going to put a 4 here. And this is actually, and this should be, I'm not sure, this is an X on here, okay, multiplied by the volume, and the volume of each one of these big squares here, each one of these is 0.1. Okay, if you're talking about these tiny squares here for WBCs, that's actually 0.004. So if we were doing red counts here, 0.004, but we're doing 0.1 for these ones. So multiplied, oops, got my eraser on, let's fix that real quick. Multiplied by 0.1, okay? So no dilution. So now we take, what's 4 times 0.1? Let's make sure we do this right. We're going to go ahead and put this 42.5 divided by 0.4. So we have 42.5 divided by 0.4 equals 106.25, which we will convert that 106, and this is per microliter of sample. Okay. The next one I want to do with you, let's take a look, because we can do this differently. I'm going to show you here real quick. Remember how I said about the 8 total? So if we took our 44 and 41 and added those, we would get, what, 85? So let's take a look at this down here. If we did 85 cells, okay, we have 85 cells, and now this is over the total cells, so that's now 8. All right, our average was 4, 85 is 8. We're going to multiply that by 0.1. All right, so that's actually 0.8. Then we're going to take 85. So 85 divided by 0.8 equals, hey, guess what? 106.25. Okay, and so that's what I want you to see, that the equation actually makes sense. And as long as you just have to make sure you're using the right number. Okay, this is per 4 cells, and this number we can actually use total as long as you use the total number of squares. And that's what's really important at your sites. Some of your sites are going to do it one way and some are the other. Just make sure you're really understanding how that's working. And so if we did have a dilution for this, if someone had made like a 1 to 100 dilution on this body fluid, we would just do 42.5 times 100 divided by the 4 times 0.1. Now this is if there was a dilution. I hope my terrible handwriting on here makes you all feel better about writing on your iPads too. Okay, so now let's multiply this. So we're going to do 4250 divided by 0.4. So 4250 divided by 0.4. Now we're going to have 10,625. Now, do we want to leave it that way? No, please say no. So we're going to count this. We're going to make it an exponential, okay? Because that's the easier way for people to see this. And if we did this as, let's make it 10.6, and that would be times 10 to the 1, 2, 3 to the third. Okay? We could make it 1.06, and that would be times 10 to the 4. Okay? Remember, it might have been a little time since you've last done this, but that is a way to do the calculations as well. All right. Thanks for listening, guys. Signing off.